Right, we are live and in the main part of the stomach, the body of the stomach.
We've moved past the cardia, and now the action is getting intense.
Yeah, lots of physiology going on here.
I mean, yeah, lots of histology supporting the physiology. Notice from far away. Let's acknowledge our layering of the wall. We have a very basophilic, dark purple staining mucosa that actually extends down to here. Then a very light staining submucosa, and then a dense pink muscularis propria stroke externa.
Yes.
Okay. Should we start with the mucosa?
Yeah,
the epithelium?
let's go with the mucosa.
Right, I'm going to center that and move in.
And actually, even at that magnification...
actually, let's back out, yeah.
Yeah, let's just have a look.
Oh, wow.
Beautiful. That is a muscularis mucosa.
Right there. There's a thin strip of muscle.
That's the way it's supposed to look.
Right down here, yeah. And then notice that I can see evidence of the, we were talking about the simple columnar cells of the stomach. They're certainly present here. The epithelium, the gastric pits actually extend way down. And we don't, it would be extraordinarily lucky, fortunate for us to catch one in section, in the plane of section, extending all the way down here. But what we see down here are cells at the bottom of the pits, basically. Yeah. And then there's a little gap between these, what are ultimately epithelial cells, and the muscularis mucosa, and this is what we call lamina propria. A little smattering of connective tissue just gluing the epithelium and the muscularis mucosa together.
And so that combination of the epithelial cells, the lamina propria, and then the muscularis mucosa gives you the mucosa.
Yeah.
So the other thing that always strikes me about this is the color shifts.
I see three bands of moving east to west there across this mucosa, across the epithelium. Actually, it seems like dark purple staining out here, dark purple staining down low, and then there's kind of a strip in the middle where it's pretty light pink.
Yeah, and that's not going to be just bad staining. That purple, pink, purple sequence.
That's real.
It's real. It's real stuff. Another thing, just go back just to finish off.
Back at 4X?
Yeah, thank you. Is that with the stomach, we talk about it having a flat surface with projections that go down, the gastric pits, the gastric glands. Yeah. As we get further on and we go into the small intestine, we're going to talk about a flat surface with upward projections.
Right. So,
And that can get tricky, but so let's just look at this.
Well,
we are seeing there a flat surface with downward projecting.
Right. So would it be fair to call this basically ground level here?
Yeah.
Like sea level?
Yeah.
And then there are projections that extend sort of in subterranean fashion down below ground level.
Yeah.
Right?
Gastric.
That's what we call them pits.
And gastric pits, yeah.
Right. Yeah.
So let's now look at those cells lining the gastric.
Okay, I'm going to advance to 10x here. Maybe 20x to see. Yeah, okay. Is that good?
Yeah, that's nice.
Yeah. So we're seeing the simple columnar epithelial cells lining the gastric epithelium here. Here we see a complete circle of cells. This lumen here is continuous with the outer with the main lumen. It's just that we've caught a pit curling into the plane of section, and we don't see its connection.
And over on the right, you see
there's a nice
something
example.
where you see the pigment there, and they actually often bifurcate like that.
Sure. Yeah. Branch.
Yeah. So a simple columnar epithelium, again, fairly light staining. They're still making a bunch of mucus. Mucus is still important here.
Yeah, I think we could conceivably distinguish between pale mucus-secreting cells and more basophilic cells that are generating enzymes and secreting stuff other than mucus.
Yeah. But mucus is important. It's as we'll go on to show with some of the other cells, we're making a lot of digestive components here. We're making acids, we're making enzymes for breakdown. You want to protect the surface itself of the stomach from the acid and stuff. So the mucus is there as a protective mechanism.
Okay, so you're saying the stomach is protecting itself from its own acid?
Oh, yeah.
I mean, why doesn't it just not secrete the acid in the first place?
Well, the acid's for digesting the food, but you don't want to digest the stomach.
Sterilizing.
If you do that, you get stomach ulcer.
Right. Okay, so the stomach has a couple of jobs here. It's a reservoir, it's a storage, it's a bag to store a meal for a period of time. There's a lot of mechanical digestion. We also have, over the course of eons of evolution, adapted the stomach to treat what is inevitably food that is laced inevitably with microbes to some degree. Even if you cook the food, it's not sterile. Well, it is after the stomach pumps a bunch of acid and sloshes the food around in the acidic contents of the stomach. That helps kill off a lot of pathogens, a lot of potential pathogens. I'm just noticing something here as an aside. I thought that when you were in the epithelium, you would not see blood vessels, and yet I'm looking at all this red staining here. This is clear. There are clearly some blood vessels. Are these blood vessels violating the rules and invading the epithelium? Is that what's going on here? No, actually, isn't this all lamina propria? Like in between, like this is a part of the epithelium. There'd be a basement membrane ringing, sort of circling this,
and it's more lamina propria.
And there's lamina propria connective tissue with blood vessels.
Yeah.
Sort of.
We're just looking at a twisted version, basically. That's
the epithelium is in little columns and islands and segments and pits. With lamina propria sort of filling in the spaces between and allowing blood vessels to get access, where of course there'll be there's not a lot of nutrients that we absorb in the stomach, but the ones that we do will be absorbed by these vessels here.
So let's move on and look at this purple transition.
Right here. So here's a sort of paler pink middle region of the mucosa.
Yeah.
Should we look in here?
Yeah.
Okay. All right. Zooming in.
And as you might suspect, you have, if we've got pink staining cells and purple staining cells, they're doing different stuff.
The form follows function.
Form follows function follows form. I never know which way it goes round and round in circles. Form and function, yes. So once we've moved below the sort of basophilic epithelial cells, those simple columnar cells that we see at the top, we see in this sort of more lavender or pink staining region, we see large cells that have, there's certainly a basophilic nucleus here, but a surround that's fairly light staining. It looks like a pale pink fried egg that you're viewing from above, looking down at the pan. The pink fried egg, yeah. That's a commonly used description of it, yeah.
Right there. Yeah. Wait, what are these? What are these cells?
Pink fried eggs.
Well, it starts with a P, I'll give you that.
Yeah, thank you. Parietal, they're called parietal cells.
Parietal cells, and what do they do?
They make acid.
Yeah, they secrete gastric acid.
HCl.
And intrinsic factor?
An intrinsic factor as well, yeah, probably. But their main digestive purpose here is hydrogen ions, chloride ions, HCl.
They're secreting gastric acid to sterilize the food. And then we get to another distinct region of the mucosa down here, where the cells are suddenly darker and more basophilic again.
So when you start seeing purple staining cells, you're thinking more of proteinaceous secretions.
Okay,
Rather than...
like a lot of ribosomal staining on rough ER, for example?
Yeah, that type of thing. Yeah. So these are the other cells that you're going to find in the gastric wall, which are the...
Are they chief cells?
Chiefly, they are.
Okay, and what is the protein that they're cranking out that gives them this basophilic staining nature? Is it pepsinogen?
Amongst many, there's a long list actually, which the students get to learn.
Okay, are we going to go through that list now?
No.
Heck no.
Make them learn it themselves. There's a long list of digestion-related enzymes that are produced by those chief cells.
Okay.
Hence, I suppose the name chief. They do a lot of the digestion.
That's a non-eponymous chief. Is it a capital C or a little c?
It's.
I think it's a lowercase c. I think it's a non-eponymous.
Professor Chief discovered them actually, didn't you know?
I don't think so.
No. Okay. So that pink-purple transition is important because it's one of the key features that let you work out that you're in the stomach.
It is a defining feature of this sort of central region, the body, the corpus of the stomach. It's got this very distinct purple, pink, purple. Differentiating different regions of the mucosa of the epithelium, actually.
Yeah.
You don't really see that kind of pattern anywhere else. It's a pattern that you see from afar. You want low power microscope, high power brain. That's how you see that.
It's the French Impressionist thing again. You don't need to be close up to get the story. You get the story from the distance.
Okay, at some point, I'm obviously going to have to do a Wikipedia dive into French Impressionism so I can figure out what the heck you're talking about. Okay.
It's French,
big picture.
It's French people who impersonate Germans. French Impressionism.
I have no.
Dr. Jollivet may have something to say about
I was just going to say, I can neither confirm nor deny. I can neither confirm nor refute. But you have your own
Franco-German faculty.
You can bounce that off Dr. Jollivet. See what she says.
Okay.
Good luck with that.
At distance, I suspect.
Yeah, right. Zooming in here, I just want to repeat.
Do we add at
revisit.
this point that Dr. Jollivet is my wife, and therefore we're not just being rude about another member of faculty?
Is she still married to you?
That's terrible judgment.
Hanging on by a thread.
Terrible taste. Good at histology, terrible with the other choice.
I noticed you're in different MDLs.
Wise.
Okay. What are we looking at here?
Okay, what are we looking at here? We are looking at the muscularis mucosa.
Yes. So this is a few layers of smooth muscle cells that actually define the boundary. Down here, we've just reached the end of the mucosa, and we enter the submucosa below that, which is just a lot of connective tissue and blood vessels and nerves.
Yeah, and then as we discussed in the cardiac part of the stomach, the muscularis externa, multi-layers, smooth muscle entirely, all for mixing and churning the contents of the stomach.
And here we see multiple fascicles of what we will surely find to be smooth muscle when we zoom in. Here, here, here. Look at this. Here's the very light staining region in between two sublayers of muscle. This might well be neural tissue of Auerbach's plexus sort. Looking over here, again, the fascicles of muscle or the sublayers of muscle don't seem neatly divided into two regions necessarily. It looks like maybe there's more than that.
Yeah.
So that's stomach.
That's our stomach vista.
Yeah.
Okay, let's see where it exits.